Chapter 1, Section 3, all about exploring real numbers. Some vocab terms that you need to know. Real numbers are the set of all numbers, rational and irrational, that we'll deal with in this class. There's also something called imaginary numbers, but we won't talk about that until Algebra 2. Inequalities are mathematical sentences that compare two expressions that are not equal to each other. Opposites are like the mirror image of a number on a number line. So mirror image around 0. And then the absolute value of a number is the distance that a number is from 0 on a number line. Remember, absolute values are always positive because it's talking about distance. So your two objectives for this lesson are to be able to classify numbers and to compare numbers. So in the real number system, there's 5 different subgroups of numbers that you need to know. Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So natural numbers are sometimes called counting numbers. And that's because those are the numbers we use to count things. Natural numbers have 1, 2, 3, on and on, forever and ever and ever. But they're the things we use to count. Whole numbers are almost exactly like natural numbers, except they include 0. So whole numbers are 0, 1, 2, 3, again, on and on, forever and ever. The way I remember this, natural numbers doesn't have an O in it, but the word whole numbers does, so it includes 0. Integers are the whole numbers plus negatives. So they start from like negative infinity, and then we get to like -3, -2, -1. They include 0, and then they start over 1, 2, 3, all the way up to positive infinity. Rational numbers is any number that can be written as a fraction, a over b. So that includes things like the number 3, because 3 can be written as 3 over 1. But it also includes things like 0.25, because that's the same as 1/4. Or like 0.3 repeating forever and ever and ever, because that, again, can be written as a fraction. Irrational numbers are things that cannot be written as a fraction. So they're numbers that are like pi. We know pi is 3.1415926, blah, 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 but we cannot write that as a fraction. Or something like the square root of 2. If you were to type that into your calculator, you would get a decimal that cannot be converted into a fraction. So we can organize these as kind of like a growing system of stuff. At the very, very beginning, we have our natural numbers. And remember, these natural numbers are included in all the other sets. And then the next thing we had was whole numbers. And whole numbers include all of the natural numbers plus 0. And then we had our integers. And remember, integers include the natural numbers, they include the 0, which makes it a whole number, and then they include negatives. And then finally we have rational numbers. And rational numbers include all of our integers, because we could always write an integer like 3 as 3 over 1. They include all the whole numbers, and then they include all the natural numbers. And then on this side we have irrational numbers. So remember, one of your objectives today was to classify numbers. I'm going to give you a number and you have to tell me what sets of numbers it belongs to. So if I give you something like 1/2, that means it's a rational number and a real number. Or if I give you something like 2, which is a natural number, that means that it's also a whole number, it's also an integer, a rational number, and a real number. So it kind of grows from inside this box. So let's do some examples. How about the number 23? Well, if we look back at this, 23 is a natural number. I could count 23 objects, which means it has to be a whole, an integer, a rational, and a real. So natural, whole, integer, rational, and real. It fits in all of those sets of numbers. Now 0 is a little different because remember 0 isn't included in the natural numbers. 0 starts with whole numbers. But because it's a whole number, it means it is an integer, it's a rational number, and a real number as well. So it's a whole number, an integer, rational, and real. Negative 173. Now remember, negative numbers can't be natural numbers or whole numbers. So we know it has to start with integers, which means that it is an integer, a rational, and a real number. Now if we take a look at 4.58, if we think about what that number means, that means we have 4 and 58/100ths. That's what this decimal part here means. We could obviously reduce that, but because this is a fraction, if we go back to our numbers, that means it's not a natural number, can't be a whole number, and it's not an integer, but it is rational because it can be written as a fraction, which means it's also real. By the way, all of your answers for these should have real numbers because those are the only numbers we're talking about. 0.33, and then it stops. 0.33 can be written as 33/100ths. And again, because it can be written as a fraction, we know that it has to be rational and real. And then finally, this should have a square root around it, and it doesn't for some reason. Square root of 32. If you were to type that into your calculator, you get some random number, and that number cannot be written as a decimal or as a fraction. So that means it has to be irrational. Anything that is a square root that's not a perfect root is irrational. So like the square root of 16 is not irrational because that's really just 4. But anything that's not a perfect square is an irrational number. So are the following statements true or false based on our classifications? And if they're false, we need to give a counterexample. And that just means give an example that doesn't work. So an example that proves it wrong. So all whole numbers are rational numbers. We can go back to our little chart here. So it's saying if you are in this box, that you're also a rational number. You're in this box here, which is true. Now the next one says no fractions are whole numbers. Let's go back to this. Whole numbers. Remember, these are our natural numbers, like our counting numbers, plus 0. So 0, 1, 2, 3, blah, 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 blah. Do these contain any fractions? Well, at first you look at it and say, well, no, they're all whole numbers. But remember, whole numbers can be written as fractions. I could write that as like 1 over 1. Or even like 6 over 6 is still 1. So this is false. And we need to give a counterexample. So a number like 10 over 5, that's a whole number. That equals 2. And 10/5 is a fraction. So there's our counterexample to prove that wrong. So part 2, the other objective was that you can compare numbers. So mathematicians have several symbols that we use. Chances are you already know some of them. We've talked about equal signs in this class. But then the less than symbol, the greater than symbol, those are the alligators. So less than starts small as you read it left to right. Some people also say that kind of looks like an L that somebody tilted on their side. Greater than is big from left to right. Less than or equal to gives us two options. It can be smaller than or exactly the same. And then greater than or equal to is kind of the same thing, just opposite. And then not equal to, we draw an equal sign and then a line through it, saying these two things are not equal. So if I give you some numbers, you should be able to compare them. So the first thing, order the numbers from smallest to greatest. So we're going to be using our inequality signs. And in order to do this, since they're fractions, we could do a couple things. We could turn them into fractions with the common denominator, or we could break out our trusty calculators. So 3/8, 3 divided by 8 is really 0.375. Hopefully we don't need a calculator for this one. It's the same thing as 0.5. And then 5/2. That's really close to 0.5, but it's 0.416, and that 6 repeats forever and ever and ever. So now it's really easy to see who's the smallest and who's the biggest. So it asks us to write it from least to greatest. So I'm going to start with the smallest one, which is 3/8. And then I have 5/12. And then finally 1/2. Now in order to show that these are increasing as I move from left to right, we want to use some of our inequality symbols. So 3/8 is smaller than 5/2, so we're going to use a less than symbol. And same thing, 5/2 is smaller than 1/2, or 5/12, sorry, is smaller than 1/2, so we're going to use another less than symbol. Finding the opposite of each number. Remember, opposites are mirror images of the number on a number line. So if I have a number line, 0 right here, 3 is right here. If I was to flip this over and find the opposite, find what's on the other side, it would be like going 1, 2, 3 on this side. I'm going to go 1, 2, 3 on the other side. And we're at -3. So the opposite of 3 is -3. I'm not going to draw this one out, but if I was to go 736 spaces on the other side of 0, we would get positive 736. -12. If I go 12 spaces from 0, I get positive 12. And 308, I would get -308. Now it's really easy to confuse opposites and absolute values, but remember, absolute value is talking about the distance a number is away from 0. And remember, distance can't be negative. So sometimes your answer for an opposite can be negative, but for an absolute value, it is always, always, always positive. So this is asking us how far is 32 away from 0 on the number line. We could draw out a number line and count, but the distance is just 32. And then how about 98, -98? If I was to count how many spaces it is away from 0, I would get exactly 98 paces. And this one's kind of a trick question. How far is 0 away from the number line? Well, it's a distance of 0. Can't make it positive, can't make it negative. It's 0 spaces away from 0. And then D should be positive 12. So you should be able to classify numbers and compare numbers. Answer these questions on your own, and we will go over them in class.